Alright, so what we'll be looking at this time is fractions. And we'll be discussing the types of fraction. We'll be discussing addition of fractions, how to subtract or otherwise minus. We'll be talking about multiplication, and we'll be talking about division. We'll also look at some mixed questions dealing with like addition and subtraction, addition and multiplication, addition and division, type of questions like that. Then we'll look at a few CXC type questions. Now, before we start the question, what is a fraction? So that's the question. What is a fraction? Now, what we probably could define a fraction as is probably we can say it's a numerical quantity that is not a whole number, or so a numerical quantity that is not a whole number can be 1/3, can be a half, it can be 3/5. So those are types of fractions. So as I said before, it's a numerical quantity that is not a whole number, because we could even write 2 over, let's say, 1, and this could be a fraction. This could be this is a improper fraction. But as I said before, it's a numerical quantity that is not a whole number, and 2 over 1 is a whole number. So we would take this out. So basically we could also say that a fraction is a part of a whole, or is a part or a fraction is something that tells us how much we have of a whole. For example, if we have a cake, let's say this represents a cake, and I'm going to divide this cake into 4 equal sections. Now, if I should shade this section of this cake, and I said that this is the shaded section is what we have. Now, this entire circle represents the entire cake. Now, if the shaded region is what is left from the entire cake, and the cake was split up into 4 parts, the 4, we would represent that as the denominator. Now, if we should put 4 over 4, this would represent 1. This would represent the entire cake. Now, if we should put what we have left out of the entire cake, we have what? We have 1 part out of, how many parts did we split the cake into? We split it into 4 parts. So we could say a fraction tells how much of a whole we have or we don't have. So we have a quarter of the cake left. Remember, the shaded region represents how much we have left, and we can say that 3/4 of the cake is missing. So if we should add the 3/4 and the quarter that we have, we're going to get what? So the denominators are the same, or we could say the bottoms are the same, so we just add the numerators. So this would be 4 over 4, which would represent the what? The entire cake. So yeah, just hope that you're getting the understanding of that. So I'm just going to shift into, let's say we have a fraction. So a fraction consists of what? Consists of a numerator, and so the top number is for this fraction is called the numerator. The bottom number is called the denominator. And this little small line here, it means to, well, could just call it a division sign. This little small line right here. So the top number represents the numerator, the bottom number represents the denominator. Now, the type of fractions that we have proper fractions. Now, a proper fraction is when the numerator is smaller than the denominator, just like the example up here. This is considered to be a proper fraction. Why? Because the numerator is smaller than the denominator. Now, we also have improper fractions. Now, So if you realize, I have two examples here for a proper fraction. We have 2/3 and we have 1/5. Here for the improper fraction is when we have the numerator bigger than the denominator. So we have two examples here. So we have 5/2, or we can consider this as a fraction in a sense, saying that it's an improper fraction. But remember, it represents a whole number, and a whole number is not a fraction. So don't let this trick you. So this, we also have mixed number or mixed fractions. Now with mixed fractions or mixed numbers, we have a whole number and we have a fraction beside it. So this is 3.5 or 1 1/3. So these are considered to be mixed numbers or mixed fractions. So enough with that. So remember, you can always pause the video, or just you can always pause the video, go back and listen to what I said before. So the first thing we're going to look at is addition of fractions. So I'm going to write it up here. So addition of fractions. Now, when we're adding a fraction, so let's say, for example, we have 2/3 plus a half. Let's say we're adding 2/3 plus a half. Now, when we're adding whole numbers, so I'm just put a little dot in here. So let's say we have 1 plus 3, and we know that 1 plus 3 is equal to 4. Yeah, but probably if we're adding this and we don't know anything about it, we would write the answer as being 3/5, in which, no, this is not entirely correct. The thing is, we cannot add fractions the same way as how we add whole numbers, but, so I'm going to repeat, we cannot add fractions the same way we add whole numbers, but this is the principle that we're going to use is the principle of whole numbers to add these fractions. Now, the principle behind these whole numbers, how is it we can add whole numbers as they are, but we cannot add fractions as they are? Now, the thing is, there's a little trick to this. I'm not sure that everybody know the trick, but beneath this 1, there's an imaginary number, and beneath this 3, there's also an imaginary number. Beneath the 1, we have a 1, and beneath the 3, we also have a 1. So if you realize this term right here and this term right here resembles a fraction, but they are whole numbers. Remember, fractions are numerical quantities that are not whole numbers. So for now, I'm just calling these a fraction because I put something beneath them. Now, because the 1 and the 3 has a common denominator, we can just go ahead and add the numerators. So remember, because the 1 and the 3 has a common denominator, we just go ahead and add the what? The numerator. So we'll get 4. 4/1. But 4/1 is the same thing as 4. Now, this is the principle that we're going to apply to add these two fractions. So basically what we need the fractions to have the same common denominator before we can add numerators. Now, let's see. 2 and 3. How can I get the denominators for these two fractions to be the same? Now, we have something that they call LCM, which means lowest common multiple. So before we can add these two fractions, we first need to find the what? Lowest common multiple. And why do we find the lowest common multiple? Because we need the denominators to be the same before we can add them, just like how we add the whole numbers. So this is what I'm going to do. The first thing, we're going to approach this from the right. So the first thing I need to do is to find the multiples for these denominators. So I'm going to find the multiples. So multiples are 2. So the first multiple of 2 is 2. Then we have 4. Then we have 6. Then we have 8. Then we have 10. Then we have 12. Then we have 14. And we can always continue. But I'm going to stop there. So these are the multiples of 2. Now multiples are 3. So I'm going to do this in a different color. Multiples are 3. We have 3, 6, 9, 12, 15, and so on, but I'm just going to stop there. Now, what we just did, we just found the multiples for the denominators. Now, we need the one that is common. So, the one that is common. So, let's scan these multiples to see what is common. So, if we can see right here, a 3 is common. Not 3, sorry, 6. 6 is common here. And what is also common? 12 is also common. So what we just did, we find the multiples, then we find what? Ones that are common, but which one do we need? We need the lowest. So 12 wouldn't be the lowest, 6 would be the lowest. So I'm just going to go ahead and write this. I'm going to rewrite the question down here. So I'm going to have 2/3 plus a half. So the LCM for 2 and 3 is 6. So I'm just going to draw a line here. So now 3 into 6 goes 2 times. What am I going to do with that 2? I'm going to multiply the numerator by that 2. So 2 times 2 is going to give me 4. Now this plus sign, I'm going to write it back down here. I'm going to bring it down. I'm not going to change the sign. I'm going to bring that down, the plus sign. Now 2 into 6 goes 3. I'm going to multiply this numerator by 3. 3 times 1 is 3. Which is equal to, now if you realize the bottoms are the same, so what we can do, we can just go ahead and add the numerators. Now probably you're saying, what, the bottoms are the same, how is that? Now this right here, I don't really want to confuse us. I'm just going to write the answer, then I'm going to explain something. So 4 plus 3, that's going to give me 7/6. So 7/6 would be our answer. Now let's look back at something. This 7/6, what does it resembles? That we went through before. Remember, 7/6, what does it resemble? It resembles what? It resembles a proper fraction, improper fraction, or mixed number. Let's see what it resembles. So remember, the numerator is bigger than the denominator, so that means it resembles a what? It represents an improper fraction. Okay, so it resembles an improper fraction. Now, what do I mean that the denominator is now the same? So we just went ahead and add the numerators. Now, before we found the LCM, which was 6. So I'm going to do this another way. So we had 2/3 plus a half. Now, remember, to add these, we need to get the denominators to be the same. To do that, we find the LCM. Now, we know that the LCM is 6. So let's look at something. Let's look at another way in which we could work this question. So remember, before we can add these two numbers, or fractions for example, we have to make the denominators be the same. Now, we know that the LCM is 6 because we found it earlier on. So how can I turn 2 into 6? What number can I multiply 2 by that would give me 6? Could multiply it by 3. Now, anything I do on the bottom here, I have to do it at the top. So anything I do for the numerator, I have to do it for the denominator. So right here, I'm going to have 3/6. Put back the plus sign. Now right here, remember, the denominators has to be the same. So how can I turn 3 into 6? I can multiply it by what? I can multiply it by 2. But remember, anything I do at the top bottom, I have to do at the top. Multiply the numerator by 2 also. So I'm going to have what? 4/6. Now, if you realize the denominators are the same, so what I'm going to do, just add the numerators and put back the same denominator, 7/6. So that is another way in which you could solve that question. So what I'm going to do, I'm going to proceed with solving another example, but it's going to be a little bit technical than this. So alright, so another example. Remember, we're doing addition. So I'm going to write, but this time instead of using, well, just start out and do another simple question. So let's say we have 3/5 plus 2/3, for example. And we're going to add these two fractions. So remember, before we can add these two fractions, we have to get the denominators to be the same. So what do we have to do? We have to find what? We have to find LCM. Now, remember, to find the LCM, we have to approach this LCM thing from the right way. First thing we have to do, we have to find the multiples, then we have to find which are common, then I have to find the lowest one. So first thing I'm going to do is to find the multiples. So if you don't know what the LCM is, it's best you do it simple. So the first thing we're going to do is to find the multiples for 3 and 5. So multiples of, let's say 3. Multiples of 3, we have 3, then we have 6, then we have 9, then we have 12, then we have 15, and I'm going to stop there. Remember, we have more. So multiples of 5 now. We have 5, we have 10, we have 15, we have 20, and we can go on with some more multiples, but I'm just going to stop there. Why? Because I realized that 15 is common so far, and it's the lowest of the multiples. So remember, we want the lowest common multiple. So 15 is the lowest common multiple, or 15 is the LCM. So let's go ahead and solve this. So I'm going to have 3 over 5 plus 2 over 3. So the LCM, what's the LCM again? LCM is 15. So I'm going to say 5 into 15 goes 5 into 15. This thing is showing a bit blurry. So 5 into 15 goes 3. I'm going to multiply the numerator by 3. So I'm going to multiply that numerator by 3. And 3 times 3 is going to give me 9 plus 3 into 15 goes 5. I'm going to multiply the numerator by 5. So we know that 2 times 5 is 10. So our answer is 9 plus 10. That's going to give us 19 over 15. So that is the answer. And again, our answer is an improper fraction. And an improper fraction is when we have the numerator being bigger than the denominator. So I'm going to skip addition now and look at or before we look at subtraction, we can try a fractional question with when we're dealing with mixed numbers. So let's see. So we're dealing with some mixed numbers now. So let's say we're adding 2 and a third plus 1 and let's say 1 and a half. Now the technique that I'm going to show you how to solve this question is we're going to change these mixed numbers or mixed fractions into improper fractions. So this is how we would convert mixed numbers to improper fraction. What we would do, we would multiply the denominator by the whole number, then add the numerator. So how do we convert mixed numbers or mixed fractions into improper fraction? We're going to multiply the denominator by the whole number, then add the numerator. So let's see. 2 times 3 or 3 times 2, that's 6 plus 1. That's going to give me 7 over 3 plus 2 times 1, that's 2 plus 1, 3 over 2. Afterwards, we're going to find the LCM. So remember, we find the LCM for 2 and 3 already. LCM for 2 and 3 is 6. So 3 into 6 goes 2. What am I going to do with the 2? I'm going to multiply the 7 by the 2. So 2 sevens, 14. Plus 2 into 6 goes 3. 3 times 3. So remember, always multiply the numerator by that number. So 3 times 3 gives us 9. Now 14 plus 9, that's going to give me 23 over 6. So 23 over 6 could be our result, or we can write it another way. We can change it to a mixed number. So after we had the mixed numbers as the question, what did we do? We use the technique as in to change the mixed numbers to improper fraction. Then we find the LCM, which was 6. Remember, if you don't know how to find the LCM, all you need to do is to find the multiples for the denominator. So after we find the multiples for the denominator, what did we do? we realized that 6 was the LCM. So after finding out that 6 was the LCM, what did we do? We divide that 6 by the denominators for each of the fractions that we had. So what did we do? We said 3 into 6. 3 into 6 goes 2 times. And what did we do? We multiplied the numerator by the 2 that we got. We multiplied the numerator by the 2 that we got, and we got 14. After multiplying the so after we multiplied the numerator with the 2 and got 14, we did the same thing to the left hand side. We did the same thing to the left hand side. So right hand side, sorry, which is I'm a bit distracted here. So we said 2 into 6 goes 3 times 3 times 3. That gives us 9. So 9 here. So 14 plus 9, that gives us the 23 over 6. So just recap it a bit. What's wrong with this camera thing? All right. So after getting 23 over 6, we identify that this is an improper fraction. Remember, when we have the numerator being bigger than the denominator, we call it an improper fraction. Or we don't have to give our answer as an improper fraction. What we could do, we could also give our answer as a mixed number. So what I'm going to do, this is how we would change our improper fraction to a mixed number. So what I would have to do, I'd have to divide the numerator by the denominator. So how many times can I get 6 out of 23? That is, we can get it 3 times. Now, that 3, we can multiply it by the 6. We're going to get what? 3 6 is 18. Now, how much can I add to 18 to get 23? That is what? 5. Now, that 5, I'm going to put it back over 6. So, we don't have to give our answer as a improper fraction. We can also give our answer as a mixed number. And remember, what did we do? I found out how many times I could get 6 out of what? 23. Or basically what I did, I divide 23 by 6. That would give me 3. Now, what can I add back to that 18? That would give me the 23. Or what can I add? After I multiply the 3 times 18, what can I add to get 23? I add 5. So 3 6 is 18, because we can backtrack this thing, 3 6 is 18, 18 plus 5, 23. So okay, we can give our answer as a improper fraction, or we can give our answer as a mixed number. So that is how we would solve addition of fractions. So what I'll be going to now is subtraction. So we're looking at subtraction. Now, I'm just going to work on probably 2 examples with this, because addition and subtraction, they're basically the same, or let's say inverse of each other. It's just that with one, the number is probably getting bigger. That's addition. And with the other, the number is getting a bit smaller. So let's see. What if we're going to start out with a very simple question? Let's say we had a half minus a third. Let's say we had this. So the first thing we'd have to do, remember, you need to know this. You need to get it synced into your skull. Whenever we're adding or subtracting fractions, we first need to get the denominators to be the same. If the denominators are not the same, we need to find LCM. So I'm going to repeat. When we're adding or subtracting fractions, we need to find what? LCM. If the denominators are different. For example, let's say we had this. Let's say we had 1 over 5 plus 3 over 5. The denominators are the same. So once the denominators are the same, we can just go ahead and add the numerators. So the answer for this would be 4 over 5. So that's the addition. So once the denominators are the same, we just go ahead, add numerators, put back the same, put back the denominator. If we're subtracting, let's say we had 4 over 5 minus 1 over 5. The denominators are the same, so we just go ahead and subtract the numerators, which would give me 3 over 5. So remember, because students tend to slip this up because I see it a lot. Sometimes when students are multiplying or dividing, they find LCM. No, you only find LCM when you're adding or subtracting fractions. So let's work this one. So we're going to subtract. Now, first thing we need to do, look at the denominators. Are they the same? No, they are not. So that means we have to find LCM. LCM for 2 and 3 is 6. And remember, if you don't know what the LCM is for the denominators, just find the multiples, and that would make it a bit easier. You choose which are common, then from the common ones, you choose the lowest. Alright, so 2 into 6 goes 3. I'm going to multiply numerator by 3. I'm going to get 3 minus 3 into 6 goes 2. Multiply numerator by that 2. I'm going to get 2. So our answer for the simple subtraction fractional question is going to be 1 over 6. So 3 minus 2, 1 over 6. So I'm going to do 1 with a mixed number. So let's say we had 3 and 1/5 minus 2 and a half, for example. So the technique that I'm going to show you, I'm going to change the mixed numbers to improper fraction, then we find LCM. So to change these mixed numbers, remember, we're going to multiply the denominator by the whole number, then add the numerator. So 3, 5, 15 plus 1, 16 over 5 minus 2 2's 4 plus 1, 5 over 2. So we need to find the LCM. So LCM for 5 and 2. So let's say I didn't know it. So what I'm going to do, I'm going to find, so LCM, that's what I'm looking for. So first thing I need to do is to find what? Find the multiples. So multiples are 2. So multiples are 2. We have 2, we have 4, we have 6, we have 8, we have 10, we have 12. And so on. We have more, so I'm going to stop there. For 5, multiples are 5, we have 10, we have 15, we have 20, and so on. But I'm just going to stop there. So, which is the lowest common multiple? So these are the multiples. So which is common? What is common so far? Only 10 is common so far, and as you can see, it is the lowest. So 10 is the LCM. So what I'm going to do, I'm going to say 5 into 10 goes 2 times. I'm going to multiply this 16 by 2, which is going to give me 32, sorry. That's going to give me 32, sorry. So put back down the subtraction sign. I'm going to say 2 into 10. That's going to give me 5. I'm going to multiply numerator by 5. That's going to 5 multiplied by 5. That's going to give me 25. So what do we have now? We have 32. We have 32 minus 25. Now 32 minus 25, that's going to give me 7. 7 over 10. So 7 over 10 would be our answer. And this 7 over 10, if they should ask what type of fraction this is not a improper fraction, nor is it a mixed number or mixed fraction, but what is it? It's a proper fraction. 7 over 10 is a proper fraction. So hopefully you're getting the gist of this. So I'm just going to move on to multiplication of fractions. So with multiplication of fractions, so multiplication of fractions. So with multiplication of fractions, this is how we're going to do it. I'm going to start out simple like I did before with the other questions. So let's say we had 3 over 5 multiplied by 1 over 2. Now, when we're multiplying fractions, first thing we need to do is to pay attention to the numbers that we have, because fractions, when you're multiplying them, you can always cancel before you multiply. And it's also best to cancel before you multiply, because sometimes if you multiply then cancel, the numbers might be too big and you're not going to be able, well, not everyone, but some students might not be able to break it down after they had already multiplied. So what you need to do, you need to check to see if anything can be cancelled. Now we have two ways, so I'm going to use the marker to indicate the ways in which we can cancel. So we have two ways. We can cancel vertically. So vertically would be this direction, you can cancel vertically, and as I show you, I'm going to work an example. Let's say we had 4 over 10, for example, and this is a proper fraction, and we need to cancel this down. So this is the cancel. This is how we would cancel it down vertically. Now 4 and 10. What is a common factor of 4 and 10? Common factor of 4 and 10 would be 2, as in what number can we use to break down the 4 and the 10 without leaving a remainder? That is 2. So 2 into 4 goes 2 times, and 2 into 10 goes 5 times. So this, when we cancel down the 4 over 10, we would get 2 over 5. So that would be an example of the vertical cancellation. Now the other way in which we can cancel is diagonally, because this up and down represents vertical, across like this, left like the floor, would represent horizontal. But what I'm referring to is diagonal. Diagonal, basically these two lines are two diagonal lines that forms an X, so we can also cancel in these directions. So what I'm going to do, I'm going to show you an example down here, even though we're going to work some example with it. So let's say we had 3 over 4 multiplied by let's say 6 over 5. So let's check the diagonals. So we have two diagonals here. We have one here and we have one here. So remember, before we multiply, we can always check to see if anything can cancel. How? Vertically or diagonally. So I did an example with the vertical here. So what I'm going to do an example with one of the diagonals here. So if we check 5 and 3, is there a number that can break 5 and 3 without leaving a remainder? No. 6 and 4, is there a number that can go into 6 and 4 without leaving a remainder? Yes, that's 2. So 2 into 4 goes 2, and 2 into 6 goes 3. So since I have already cancelled it down, I'm just going to go ahead and multiply. So I'm just going to write a little arrow here. So when you're multiplying fractions, what would we do? We would, after we look to see if anything can be cancelled, the next thing we need to do is to multiply across. And what do I mean by multiply across? I do not mean multiply 3 times 5 or 2 times 3. No, I'm going to multiply numerator with numerator and the denominator with denominator. So I'm going to have 3 times 3, which is going to give me, see, I almost made that mistake by multiplying the 3 times 5. So it's very easy to make a mistake, you know. So remember, you should multiply. After we finish with the cancellation, we should multiply what? Top number with top number, or more appropriately, numerator with numerator, denominator with denominator. But if you don't remember the terms so clear, what you could do, you could multiply top number with top number, bottom number with bottom number. So let's multiply top numbers first. So 3 times 3, that's going to give me 9, divided by 2 times 5, that's going to... So let's go back to the one that we started with first. So this, first thing we need to do, check if anything can be cancelled. If there isn't anything that can be cancelled, we multiply what? Numerator with numerator, denominator with denominator. So let's check to see if anything can be cancelled first. So 3 and 2, is there a number that can go into both 3 and 2 without leaving a remainder? No. Well, 1 can, but it's not going to make it any simpler. So this diagonal cannot be simplified or broken down. This diagonal, no. So all we need to do is to multiply across top number with top number, bottom number with bottom number, or numerator with numerator, denominator with denominator. So and it doesn't really matter if you multiply denominator with denominator first, or numerator with numerator first, or numerator with numerator first and denominator with denominator first. It doesn't really matter. You end up with the same answer. So 3 times 1 is going to give me 3, and 5 times 2 is going to give me 10. That would be our result. Now let's look at another example. So let's say this one, I'm going to make it a bit harder per se, so I'm just going to use some mixed numbers. So let's say we had 1.5 multiplied by 2 1/3. So the first thing we're going to do, we're going to change these mixed numbers to improper fraction. So what I'm going to do, I'm going to say 2 times 1, that's going to give me 2. 2 plus 1, that's going to give me 3/2. Multiplied by 3 times 2 is 6 plus 1, that's going to give me 7/3. Our result. Now remember, first thing we need to check and see if anything can be cancelled. It's not incorrect if you multiply then cancel, but I'd rather if you check to see if anything can be cancelled, then multiply afterwards. So let's check the diagonals. So this diagonal 2 and 7, no. This diagonal 3 and 3, yes. 3 into itself 1, 3 into 3, 1. So what we're left with, 1 here, 7 here, 2 here, 1 here. So let's multiply numerator with numerator, then denominator with denominator. So I'm going to have 1 times 7, which is going to give me 7 over 2 times 1, that's going to give me 2. So that's an improper fraction. So remember, we can give our answer as a mixed number. So I'm just going to separate here, and let's see if we can figure out the mixed number representation for 7/2. So what I'm going to do, I'm going to say 7 divided by 2, that's going to give me, use a different color, that's going to give me 3. Now there's a remainder. What's the remainder? 2 times 3, that's 6. So that means the remainder is 1. That 1, I'm going to put it back over the denominator. So the answer to this question can be 7/2 as an improper fraction, or 3.5. That's as a mixed number. So that would be our answer for that question. So I'm going to move on. I'm just going to do another example of multiplication using mixed numbers. Then we're going to look at division. So use this marker, use this one. So let's say we had 5.5 multiplied by let's say we had how can we put this? Let's say we had like 3 2/3. We're going to multiply this. So let's see. So the first thing I'm going to do, I'm going to change these numbers to improper fractions. So I'm going to multiply 2 times 5, that's going to give me 10. 10 plus 1, that's going to give me 11/2, multiplied by 3. 3 is 9 plus 2, 11/3. Now 11/3, 11/2, let's multiply. Now we cannot cancel anything, so we multiply top number with top number, bottom number with bottom number, or numerator with numerator and denominator with denominator. So what we're going to do, we're going to have 11 times 11. Now 11 times 11 is the same thing as 11 squared. That is going to give me 121 divided by 2 times 3, that's going to give me 6. Now this would be our answer as an improper fraction. That would be our answer as an improper fraction. Now we could change our answer to a mixed number. So this is a mixed number. We could say, all right, 6 into 121. We could say 6 into 12, that's going to give me what? 2. So I'm going to say 20. So 6 into 121 goes 20. 20 times 6, that's about what? 120. So we have a remainder. Remember, the remainder, we're going to put it over the denominator. So 6 times 20 is 120. 120 plus 1 is going to give us 121. So that is how we would convert the improper fraction to a mixed number. So let's move on to division now. So just like how we had addition being the opposite of minus or subtraction, multiplication and division, they are also the opposite of each other and they go hand in hand. So let's work a division question. So let's say we had, for example, 3 over 2 divided by 4 over 3. Now, with the division sign, we cannot work with the division sign. So what we need to do, we need to change this division sign to multiplication and reciprocate the fraction behind the sign. So what am I going to do? So I'm going to, come on, camera go blurry. So what I'm going to do, I'm going to rewrite focus. So I'm going to rewrite the first fraction. I'm going to have 3 over 2. So remember what I'm going to do, I'm going to change the division sign to multiplication, then reciprocate the fraction behind the sign, or flip. So if you don't know what reciprocate means, it means to flip. So we're going to flip it. So when you flip 4 over 3, we're going to get 3 over 4. So if you realize what we did, we end up with multiplication. So we just go ahead, check to see if it can be cancelled. If there isn't, we just multiply across, or multiply numerator with numerator, denominator with denominator, or top number with top number, bottom number with bottom number. So 3 times 3, that's going to give us 9, and 2 times 4, that's going to give us 8. So that would be our result. And why I always change the improper fraction to a mixed number is because you don't know what they can ask you in the exam. So yeah, all right, so let's do another example of this division. So let's say we had 1 2/3 divided by 2 1/5. So what I need to do, the first thing I need to do is to change these mixed numbers to improper fractions. So 3 times 1 is 3 plus 2. 5 over 3 divided by 2, 5, 10 plus 1, 11 over 5. Next thing I'm going to do, remember, we cannot work with the division sign, cannot work with it. So we need to change this division sign to a multiplication sign, then flip the fraction behind the sign, or reciprocate the fraction behind the sign. So what I'm going to have, I'm going to rewrite the first fraction, change the division sign to multiplication, then flip the fraction behind the sign. Now check to see if anything can be cancelled. We check vertically first, then we check the diagonals afterwards. So we would have what? Cannot cancel anything. So we just multiply numerator with numerator, so that's 25, and denominator with denominator, that's going to give us 33, and that's a proper fraction. So that would be our answer. So that's it for addition, subtraction, multiplication, and division of fractions. So remember, you can always pause the video and look over to see if you can get a proper understanding. So what I'm going to do now, I'm just going to probably run this video for probably an hour. What I'm going to do, I'm going to do some mixed questions. So I'm going to look in this. You can realize this is a Caribbean upper secondary level mathematics work, book 1, past exam questions, works with work solutions. I guess the solutions are at the back, so we're not going to look at the solutions right now. What I'm going to do, I'm going to look at the questions. So the first question in this book that we're going to look at is this one. So with this question, I'm just going to rewrite it here. I'm going to rewrite the question here, so hopefully each person can see the question. So this is a 2000 and what? Paper is falling. So this is a 2005 question 1A. So this question says what? 4 1/5 minus open bracket 1 1/9 multiplied by 3 close bracket. So with a question like this, we need to follow BOMDAS. So I'm not sure if you're familiar, if everybody is familiar with working with BOMDAS. So we have BOMDAS, BOMDAS, and we have PEMDAS, PEMDAS. So let's look and see what these terms mean. Now, BOMDAS, very easy, probably a lot of persons remember that. PEMDAS is the same thing as BOMDAS. Now B, so this would basically represent the order operation. So with mixed signs. So the first thing we need to do if we're working an operation, first thing we need to look if there's a bracket. So if there's a bracket, we're going to work inside the bracket first. Next, we're going to do the off section next, but this O represents like powers. Like for example, if I have 2 to the third, this 3 at the top represents a power, and 2 cube is 8. So we would do that. So after we do bracket, we would do the power, then we do multiplication, then we do division, then we do addition, then we do subtraction, which is the same thing here. P means parentheses, which is the same thing as brackets. I'm going to repeat. P means parentheses, which is the same thing as what? Brackets. Now this E is the same thing as the O here. The E means exponent, because this is a power. This 3 is a power, but it's also called an exponent. So we would work parentheses first, which is the same thing as bracket. Then we work anything with exponent afterwards, which is the same thing as this O, which is the off. Then we work multiplication, then division, then addition, then subtraction. So let's look at this question. So with this question, what do we have? We have a bracket. So we're going to work inside the bracket first. But not because we're working inside the bracket first. That doesn't mean I'm just going to leave this side here. What I'm going to do, I'm going to change everything to improper fractions. Now, I'm going to have 4, 5, 20 plus 1, 21 over 5 minus open bracket. Remember, I'm working the bracket first. So I'm going to have 9 times 1, that's 9 plus 1, 10 over 9 multiplied by 3 over 1. Close my bracket. Why did I change it to 3 over 1? Because I want to resemble a fraction, even though it's a whole number. But it resembles a fraction now. So first thing we need to do before we solve this inside the bracket, we need to check to see if anything can be cancelled before we multiply. So 3 into itself. So let's use a different color marker. So we can use 3 to break down this diagonal. So 3 into itself 1. 3 into 9, 3. So what I'm going to have 10 times 1, 10 divided by 3 times 1, 3. Put back my subtraction sign, put back my 21 over 5. So the answer for inside the bracket is 10 over 3. So the next thing I'm going to do is to work it with the minus sign. Now, remember, when we're adding or subtracting fractions, the first thing we need to do is to do what? Find LCM. The LCM for 3 and 5 is 15. 5 into 15 goes 3. 3 times this 21 is going to give me 63 minus 3 into 15. That's going to give me 5. 5 times 10, that's going to give me 50. Now 63 minus 50 is going to be 13 over 15. And this would be your answer if you were in the 2005 ME exam. That would be your answer or your result. So let's see if we have any more questions in this book. Okay, we have another question which is a bit trickier than the previous one. So let's see. Let's see what we have. So I'm going to turn the page like this. So with this question, just separate this here. So with this question we have what? We have 2 1/4 multiplied by 4 over 5 all over 3 over 5 minus 1 over 2. So if you realize this question is a bit different from the ones that we have worked before. So now let's see what if we can identify what we have. What we have is the top. We have a top. So we have a top. So I'm just going to label my fraction. I have a top and I have a bottom. Now what I'm going to do, I'm going to work the top first. So I'm going to indicate what I'm working first. I'm working the top first. Now for the top, I'm going to change the mixed numbers to improper fractions. So I'm going to have what? 2 4s, 8 plus 1, 9 over 4 multiplied by 4 over 5. So remember, always check to see if anything can be cancelled when you're multiplying fractions. Now 4 into itself, 1. 4 into 4, 1. Anything can be cancelled? No. Equal to, I'm going to multiply across, but numerator with numerator, denominator with denominator. 9 times 1, that's going to give me 9, divided by 1 times 5, that's going to give me 5. So this is my answer for the top. Now I'm going to write the bottom section now. I'm working the bottom section now. So the bottom section, we have what? We have, we're going to use a different color to work the bottom section here. So for the bottom section here, we have what? We have 3 over 5 minus a half. So what I'm going to have to do, I'm going to find LCM. The LCM for 5 and 2. Remember, whenever you're adding or subtracting fractions, you need to find LCM. Now, LCM for 5 and 2, that's 10. 5 into 10, that's what? That's 2. I'm going to multiply numerator by 2. I'm going to get what? 6 minus 2 into 10. That's what? 5. 5 times 1. I'm going to get 5. So the answer that we have for the bottom, or the answer that we're going to get for the bottom, is when we subtract 6 minus 5, that's going to give me 1. 1 over 10. So now we have an answer for the top section and we have an answer for the bottom section. Now, what does this big hell over line that look dangerous, what does it mean? It means that we're going to have to divide the top answer by the bottom answer. So this is how I would write it if I'm in an exam. I'm going to write what? I'm going to write top divided by bottom. That's what I'm going to do, because if I should write it the other way around, it would be incorrect. So remember, we have a top, then we have a bottom. Remember, this line means to do what? This big line means to do what? It means to divide. So the answer that we got for the top, we're going to put it on the left hand side. Answer for the bottom, we're going to put it on the right hand side. Now the answer for the top was what? It was 9 over 5 divided by, and so we got for the bottom was what? 1 over 10. So remember, we cannot work with the division sign. So what I'm going to do, I'm going to rewrite the first fraction. I'm going to change my division sign to a multiplication sign. Then I'm going to reciprocate this 1 over 10. It's going to turn 10 over 1. After I had reciprocated it or flipped it, I'm going to have to multiply. Remember, always multiply. Always check to see if anything can be cancelled before you multiply. So what I'm going to do, I'm going to check the diagonals first. So I'm going to cancel 5 and 10. Which number can go into 5 and 10 without leaving a remainder? 5. So 5 into itself, 1. 5 into 10, 2. Now let's check the other diagonal. 1 and 9. Well, yeah, 1 can go into 9 and 1 without leaving a remainder, but it's not going to change anything. So what we're going to have to do, multiply numerator with numerator, denominator with denominator. So I'm going to have what? 2 times 9 or 9 times 2. That's going to give me 18 over 1 times 1, which is 1. So the answer is 18 over 1, which is the same thing as 18. So that is how we would solve that particular question. So I'm just going to work a few more examples. And remember, these are past paper questions. So worked one like that before. Work one like this now. So with this one, this is a 2008 May question. We have 2.5 minus 4 over 5 all over 3 over 4. So remember, I'm going to label what I have. So with this fraction, we have a top and we have a bottom. So what am I going to do? I'm going to work the top first. So I'm indicating the section that I'm going to work first, so top. So with the top, I'm going to change the mixed numbers to improper fractions. So I'm going to have 2 times 2, which is 4, plus 1. That's going to give me 5 over 2 minus 4 over 5. Remember, whenever we're adding or subtracting fractions, we always find what? LCM. So the LCM for 2 and 5 is 10. Remember, if you don't know how to find the LCM, or you don't remember what the LCM is out of your head, always find the multiples for the denominators. So what I'm going to do, this is nice in the background, I just hope it don't affect it. Alright, so what I'm going to do, I'm going to say 2 into 10, that's going to give me 5. I'm going to multiply the numerator by 5, so 5 times 5, that's going to give me 25. Minus 5 into 10, that's going to give me 2. 2 times 4, that's going to give me 8, equal to, now 25 minus 8, that's going to give me 17. 17 over 10. So that would be my answer for the top part of the question. Then look at the bottom. Now at the bottom part of the question, we don't really have anything that can be worked out. It's just a singular fraction, a proper fraction. So we don't have to work anything. So what I'm going to do, I'm going to write top divided by bottom. So the answer that we got for the top was what? 17 over 10 divided by the answer that we have for the bottom is 3 over 4. So remember, we cannot work with the division sign, so I'm going to change it to what? Multiplication and reciprocate this fraction. So I'm going to have 4 over 3 equals to, now before we multiply, always check to see if anything can be cancelled. So let's see, yes, so let's say we have 2 can go into 4 and 10 without leaving a remainder. So 2 into 4 goes 2, 2 into 10 goes 5. After we finish with cancellation, then we're going to multiply the numbers across. So 2 times 17, that's going to give us 34. 3 times 5, that's going to give us 15. Now this is an improper fraction. So this is our final result, but this is an improper fraction. So what if they say that they want the answer as a mixed number? So we write R, so the answer as a mixed number is going to be, so 15 into 34 is going to give us 2. Remainder 4 over 15. So we can always check it back. 15 times 2 or 2 times 15, that's going to give us 30. 30 plus 4, 34. So this is our answer as a mixed number. So let's see if we can find another example that is a bit different from the one that we worked before. Oh, look at this one. This one is a bit tricky. This one is a bit tricky. So what, let's say we had what? We had 2 and 4 over 9. This line here, 4 and 2 over 3 minus 3 over 7. And this is what? This was a January question, January 2011. So this question, see a question like this, you're going to say, what type of question is this? What am I going to do first? We have to look back to what? We have to look back to BOOMDAS or PEMDAS. So when we look at BOOMDAS, what can we identify? Do we have any brackets? No. Do we have any powers? No. Do we have multiplication? No. Well, not that we can see right now. Do we have division? Yes, we have division. This line right here represents division. So the first thing we need to solve is this section of the question. We need to solve that section first. So what I'm going to do, I'm going to rewrite it. I'm going to manipulate this question. Manipulate means to change it to the way how I'm familiar with it. So I'm going to rewrite it as 2, 4 over 9. Put the regular division sign that I'm used to. 4 and 2 over 3 minus 3 over 7. But remember, I'm going to solve which section first? I'm going to have to solve the division section first. This section, I'm going to have to solve this section first. Then I move on to the subtraction afterwards. So solve this first, then solve this afterwards in this particular question. All right, so let's get into this question. So what we're going to do, we're going to change all the mixed numbers. Don't mess up the book. We're going to change all the mixed numbers to improper fractions. So what I'm going to do, I'm going to say 2 times 9, that's 18. 18 plus 4, that's going to give me 22 over 9 divided by 4 3s 12 plus 2, 14 over 3. Put a bracket around it to indicate that I'm working it first. By 3 over 7. Alright, so not because we're solving in the bracket first, that doesn't mean I can just leave this out. I'm bringing it with me. Meanwhile, I'm solving inside the brackets. Alright, so remember, we cannot work with the division sign. So I'm going to change the division to multiplication, then flip the fraction behind the sign. So I'm going to have 22 over 9 multiplied by 3 over 14, close back my bracket, 3 over 7. Okay, now I'm going to check to see if anything can be cancelled. We know that yes, this diagonal, we can use 3, 3 into 12, 1, 3 into 9, 3, 2 into 14, 7, 2 into 22, that's 11. Then I'm going to multiply across. 11 times 1, that's 11. And 3 times 7, that's what? 21. And bring back down my minus 3 over 7. So this is the answer that we got for the bracket section. So I can just remove my bracket and put down the 3 over 7. So this is what we are left with. This is what we are going to work. That would give us our final answer. Now, what's the LCM? Because we're subtracting. So what's the LCM? The LCM is 21. Why is it 21? Because probably some persons would say the answer is 42. 21. 7 can go into 21 without leaving a remainder. 21 can go into 21 without leaving a remainder. So 21 into 21, that's 1. 1 times 11, that's 11. Minus 7 into 21, that's 3, because 3 7 is 21. So multiply this by 3. So 3 3 is 9. So what I'm left with, 11 minus 9, that's going to give me 2 over 21. So this would be our result, and that result is a proper fraction. So this was a pretty awkward question. So what you can do, you can just remember, you can always pause and rewind and go again to solve the question. So I'm just going to look for 2 more questions that are kind of a bit different. All right, what about this one? So this one came on the January 2012 CXC past paper. So this is what? This is 1 3/4 all squared divided by 3 1/2. So this is another awkward question. So as I said, this was a 2012 January paper, past paper question. So with this one, I'm going to change because looking at this question, obviously we need to follow BOMDAS again. So BOMDAS. So with BOMDAS. But before I looked at BOMDAS, what I'm going to do, I'm going to just simply change everything to improper fraction to make it a bit simpler, or make it seem a bit simpler. So I'm going to change to mixed numbers. So 4, that's plus 3, that's 7 over 4 all squared divided by 6 and 1, 7 over 2. Now, why I'm working so fast is because by now you should be able to, or you should have some ideas as how to change from mixed number to improper fraction to mixed number. So let's look at BOMDAS. Do we have any brackets? Yes, we just change the mixed numbers to improper fraction inside the bracket. Now the O, that is the next thing we're going to do. The O refers to the exponent. That means we're going to have to square whatever is inside the bracket. And remember, squaring a number is multiplying it by itself. So 7 over 4 squared is the same thing as 7 over 4 multiplied by 7 over 4, which is 49 over 16. So squaring 7 over 9, that's going to give us 49 over 16 divided by 7 over 2. You didn't have to rewrite that still. Probably could have changed the division sign to multiplication from here, then flip. But I'm just showing the steps. Alright, so we would have 49 over 16 multiplied by 2 over 7. Now remember, whenever we're going to multiply, always check to see if we can cancel. And yes, let's look at the diagonals. 2 into itself, 1, 2 into 16, 8, 7 into itself, 1, 7 into 49, 7. So our result, our final answer, is going to be 7 times 1, 7 over 8 times 1, 8. That would be our result for that question. All right, let's see if we can find another one. All right, so these seem like questions that we have worked already. So let's draw for some past papers over here. Work one like this already. That. Seems like I'm going to have to make up another question or make up a few questions, even though have past for questions. So let's make up another question and see. What if we had something like this? 1.5 minus 2, let's say plus 2 and a third multiplied by 3 over, let's say, 2, for example. And you see questions set up like that. And we're supposed to solve it. Now, which section would we solve first? So remember, we have BOOMDAS. BOOMDAS is going to tell us which section would work first. So looking at this, BOOMDAS, do we have any brackets? No. Do we have anything with exponent? No. Do we have multiplication? Yes. So this is the section we're going to work first. So I'm going to change everything to improper fraction. This is already in improper fraction forms. I just need to change these. So I'm going to have, just use this color and done. So we have 2 ones, 2 plus 1, 3 over 2 plus 6 plus 1, 7 over 3 multiplied by 3 over 2. And remember, we're working this side first. So what I'm going to do, check to see if anything can be cancelled. So I'm going to cancel here. 1, 1, 7 times 1, that's 7. 1 times 2, that's 2. Bring down back my plus sign. Bring back down my 3 over 2. The denominators are the same. So what we're going to do, go ahead and add the numerators. So I'm going to have 3 plus 7, that's 10. 10 over 2, it's going to give me 5. So 5 would be the result for that question. All right. So let's work another example. This one a bit different. Let's say we had a question with only multiplication and division. So let's say we had 3 over 5 multiplied by 2 over let's say 3 divided by 1 and 1/3. So the first thing we need to do, change everything to improper fractions. So I'm going to just rewrite 3 over 5 multiplied by 2 over 3 divided by 3 1 3 plus 1 4 over 3. Then remember, the inverse for multiplication, or the opposite of multiplication, is division, or the opposite for division is multiplication. So we can go ahead and just solve everything at once. But before we go ahead and solve everything at once, I'm going to change this division sign to multiplication, then flip this fraction. So I'm going to have 3 over 5 multiplied by 2 over 3 multiplied by 3 over 4. Then I'm going to check to see if anything can cancel across this. So let's see, 3 into itself 1, 3 into this 3, 1. We cannot touch this 3 because we don't have anything across the diagonals to cancel. So we cannot touch that one, only these 3. Now what else can we cancel? 2 into itself 1, 2 into 4, 2. Now after we finish with cancellation, I'm just going to multiply across. So 1 times 1, that's 1 times 3, that's 3. All over 5 times 1, that's 5. Times 2, that's 10. So our answer is 3 over 10. And remember, it's separated by a multiplication sign. So 1 multiplied by 1 is 1. That 1 that we got multiplied by 3, we got 3. 5 times 1, that's 5. 5 times 2, that's 10. So that would be our result. Let's work another example. What if we had 1.5 plus 2 1/3 minus 3, for example. Now, first thing we need to do, see if we can change everything to improper fraction. So I'm going to have 2 ones, 2 plus 1, 3 over 2 plus 3, 2, 6 plus 1, 7 over 3 minus this 3. I'm going to put it over 1 because remember it has an imaginary 1 beneath it. So the next thing we need to do is to find LCM. Remember, whenever we're adding or subtracting fractions, we always find what? LCM. So the LCM for 2, 3, and 1, that's 6. 2 into 6 goes 3. 3 times 3, that's going to give me 9. Plus 3 into 6 goes 2. 2 times 7, that's going to give me what? 14. Minus 1 into 6, that's 6. 6 times 3, that's going to give me what? 18. Now let's see if we can add these. So 9 plus 14, that's going to give me 23. 23 minus 18, that's going to give me what? 5. So 23 minus 18, that's going to give me 5 over 6. So that would be my result for this question, and it's a proper fraction. So that would be our result, and that's it for fractions. So maybe the next question that I create is going to be on decimals, and when you're working decimal questions, you need to have an idea about significant figure, standard form, and stuff like that, and that's what we're going to look at next in our next video. So I hope everyone enjoyed this video, and sorry about the noise in the background and stuff like that. All right.